The following is a presentation of Video Lab Report number 5, analyzing the free throw attempts of NBA players. As the title suggests, the primary objective of this lab was to track the physical interactions of a basketball free throw attempt in a real environment. The true purpose was to determine both the initial velocities and initial forces with which two different NBA players shot their free throws. These experimental results would then be compared against a computer model's prediction. Through both experimental data and predicted data, it was determined that each player shot the ball with a different initial velocity, but with a coincidental and almost identical initial force for their respective foul shots. It should be noted that the standard mass of an NBA basketball is 0.624 kilograms, and the horizontal distance between the basketball hoop and the foul line is 4.52 meters. The displacement of the basketball was tracked from the moment it left the player's hands until the moment when it completely passed through the basketball rim. Three forces were in play in the analyzed system: the initial force of the shot, the force of gravity, and a drag force. Shown here is LeBron James' free throw attempt in tracker. The shot was tracked to have a max height of 1.69 meters above release point over a time interval of 1.12 seconds. The initial velocities in both the x and y directions are shown here. These velocities were used as initial conditions in the VPython model. The energy principle was used to calculate the velocity with which the basketball was initially shot at. By considering the change in kinetic energy and the change in gravitational potential energy, it was determined that LeBron shot the basketball with an initial velocity of 5.75 meters per second. Note that the mass of the basketball is divided out, the fractions are cleared, and the negatives are negated to create positive calculations. This calculated velocity could then be used to calculate the experimental force with which the basketball was shot. Through derivation of Newton's second law, it was determined that LeBron James shoots his free throws with a net force of 3.20 newtons. In VPython, initial conditions such as initial velocities from tracker, little g, k the drag constant, and tf were set as parameters. Then, during the loop, the net force, position, and velocity of the ball were updated during its 1.12 second trajectory. As shown here, the VPython model underpredicts the time interval over which the ball travels, the displacement of the basketball, and also the net force with which LeBron shoots. TF should be equal to 1.12 seconds, delta R should be 4.52 meters, and FNet should be 3.20 newtons. An identical approach was taken to analyze Dwight Howard's free throw attempt. As seen in tracker, Howard's free throw reaches a max height of 1.35 meters above release during a time interval of exactly 1 second. The initial velocities in both the x and y directions are shown here. These velocities were again used as initial conditions in the VPython model. Likewise, the energy principle was used to calculate that Dwight Howard shoots his free throws with an initial velocity of 5.14 meters per second. This velocity was used to calculate that his free throws are shot with a net force of 3.21 newtons upon release via Newton's second law. Through the same VPython model, it was shown that the model overpredicts the time interval and displacement of Howard's free throw, yet again underpredicts the net force with which the basketball was shot at. TF should be 1.00 seconds, the x displacement should be 4.52 meters, and the net force should be 3.21 newtons. Recall that all of these calculations and predictions were completed using two fundamental physics principles, the energy principle and Newton's second law. It was evidenced through the experimental data and projected model that the initial conditions of the NBA players' shots were indeed different. LeBron's release velocity was equal to 5.75 meters per second, while Dwight Howard's release velocity was calculated to be 5.14 meters per second. This could perhaps be attributed to the difference in height between the two players. Dwight Howard is 2.11 meters tall, while LeBron is only 2.03 meters tall. According to experimental data, it can be concluded that a man who is 6'8" should shoot a basketball with an initial velocity of 5.75 meters per second. Alternatively, a man who is 6'11" should shoot a free throw with an initial velocity of 5.14 meters per second. Coincidentally, it was determined that, regardless of height, an ideal initial shooting force for foul shots should be approximately 3.2 newtons. Although a correlation between model data of the two foul shots was examined, it was indeed different from the experimental calculations of the tracker data and simple fundamental physics principles. By that reasoning, one should follow the calculated velocities and forces with which to shoot a free throw in a real-world physics system. Thank you for watching.